Yes, this is a function because the x values don't repeat. Here, do the x values repeat?
Yes.
Yes, x values repeat, and you've got different y's for them, right? So this is not a function. Is C a function? Yes. Okay, what about the next one? No, the next one is not a function. The way you know it, if you solve for y, you should only have one value if you put in an x. So what do I mean by that? So there are two ways that you can figure this out. One is if you solve for y, right, take a square root, y is equal to plus or minus the square root of x over 2. So that means, pick an x. Suppose x is 1. If I put 1 in here, what's y? Plus or minus 1 over 2, root 1 over 2, correct? So for one x value, I have two y's. Okay, so if x is equal to 1, y is equal to plus or minus root 1 over 2. Because you have two different values for an x value, for an x point coordinate, then it's not a function. Okay? All right. Now, function notation, you all know. F of x, right, represents a function. So when you have f of x, the f is the name of the function, and x is the variable in the function. So it doesn't always have to be f of x. It could also be h of x. It could be v of t, right? It could be a of r. Okay? So when I have a of r, what that tells me is, okay, that I have a function, the name of it is a, and the variable that's used in the function is r. Okay? Another way to see that is the x is always going to represent values of the domain, okay, horizontal axis, and that's the independent variable, okay? The y are the f values, and it's the dependent variable, okay? Questions? Okay. You guys remember this? We did this with sine and cosine before? Okay, now it's back. And it's going to be, repeating, because in chapter 12 and in calculus, you're going to need this. So we need to, learn how to build it from now. So for each function, find f of a and this. So we have to do two things for this, okay? So if this is f of x, what's f of a? Yeah. Okay. So that's number one, f of x. Now, what I need is the other one. F of a plus h minus f of a all over h. So let's see what that is, okay? Okay, let me color code this. Okay, what's f of a plus h? Instead of f of x, now I want f of a plus h. So instead of x, what am I going to put for all the x's? Not a, I want a plus h. I want f of a plus h. Okay, so think about this. F of x is x squared minus 2x. F of a plus h means all the x's got replaced by a plus h. So this is going to be a plus h squared minus 2 a plus h. Okay? What's going on? So a plus h squared minus 2a plus h. Okay? Minus 2a, but with a parenthesis, right? All over h. So this is going to be now, I need to distribute. Okay, a squared plus 2ah plus h squared minus 2a minus 2h minus here a squared plus 2a all over h. So no pre-calc here, just algebra. Okay? And then you have to see if things simplify. The a squares go away. I have and the 2a's go away. So what do I have left? 2ah plus h squared minus 2h all over h. Now you can factor out an h. All over h, and those h's cancel. So finally I get 2a plus h minus 2. And the order in which you write those doesn't matter. Okay? So, we have f of x, and we were trying to build this. Okay, yes?
I'm confused when we got f of a equals a squared minus 2a.
So the question said, first find f of a, then find this.
But how did you find f of a?
So this is the function f of x. If I asked you for f of 2, what would you have done?
Put 2 and
X. Now I'm asking for f of a. So now you put a instead of all the x's. Okay? So so if I asked you for f of r, what would it be?
So the r squared minus 2r.
Exactly. Okay? And then when you do this, you use f of a again. Okay? All right. Yes, Gabe.
So, like, how did you get the minus a squared minus 2a, like on the third one on the top? I understood the first two, but
okay. So this is f of a plus h. It's all the red stuff.
Yeah, I get that.
Minus, what's the recipe calling for? F of a. What's f of a?
Yeah, a plus
f of a is when you put a in here. That's what it comes from. Okay, last question, yes.
Why couldn't you take out the h in the denominator?
We did. I crossed it out here.
No, like when you were taking the h's out.
Oh, well, because there was only a common term in here to take out the h's from. This is just a single term, so I don't have to factor anything out. Okay, now.
Can we turn off the light that's like right here?
Okay, so now we have f of x equals 3. So take a look at this. F of x equals 3 looks like this. Okay, so basically it's a graph of y equals 3. So when x is 0, y is what? 3. So f of 0 is what? 3. What's f of 5?
3.
What's f of 7?
3.
What's f of negative 3? Okay, so can you take off your head? Thank you. So no matter what, f is always 3. So that means when the problem asks for f of a, how much is that? 3. So now when the problem asks for this, okay. So what's f of a plus h? Nope. 3. So f of anything is 3, yes? Minus what's f of a?
3.
Over h. So that's 0 over h, 0. Okay? Yep.
I'm sorry, why is it always Why when you add the h is it 3?
Because f of a is 3. F of 7 is 3. No matter what, so this is the x value, okay? No matter what the x value is, the y value, or f, is always 3. Okay, let's talk about domain. If you have a function and you're not specifically told what the domain is of that function, then it has an implied domain, which is the set of all numbers for which the expression is defined. Okay? So, how do you find the domain? It's easier to find all the numbers where the function is undefined. Okay? Exclude those, and then whatever remains is the domain. So, we're going to exclude values that would result in division by 0 or taking the root of a negative number. So there are two areas that we're going to focus on right now where we might run into a domain issue. One is if you have a rational function where the denominator might be 0, that's no good. Another one is if you have a root. So, take a look at the first one. We know that this creates a problem, okay? So you say, okay, x plus 2 can never be 0. So when is x plus 2 0? At x equals negative 2. That means at x equals negative 2, I have a problem. The function doesn't exist. When I exclude that from the number line, all the other points are places where my domain exists. Okay? So what are those regions? It's from negative infinity to negative 2. So I write that like this, negative infinity to negative 2. And also from negative 2 to infinity. Okay? All right.
But that's just in
Now,
this case,
right, we're going to do thousands of cases. Okay. What about this one? This one is a root. The issue here is that the stuff inside the root, we call it a radicand, should be greater than or equal to 0. So x minus 2 should be greater than or equal to 0. That means x has to be greater than or equal to 2. That's where I get all the numbers that make my function real. Okay, I write that like this, 2 to infinity. Okay, all right, so let's do some domain examples. I've split up the realm of functions into 3 right now. We're going to go from polynomial functions to some where we have issues. Polynomial functions are nice and easy, but kind of boring. The domain of all polynomial functions is all real numbers. Okay? How do you know if it's a polynomial function? You basically have variables with an exponent of 0 or a positive integer, right? X to the 0, x to the 1, x to the 2, x to the 3, whatever. Okay. So, don't even think about, you don't even have to think about the domain for these. It's automatically negative infinity to positive infinity. And here too, negative infinity to positive infinity. Because there is no value of x that when you plug it in here, you're gonna get an undefined number, right? Like whatever you plug in for x, you get a real number for y, correct? Okay. Okay. We have a problem with rational functions. Oh. I can't. Oh no, my pen stopped working. And so did my computer. Okay. So what's the problem with rational functions? Is that the denominator can't ever be 0. So whenever you see a rational function, the first thing you want to do is factor the denominator. So, huh? Okay. So how does that factor? Right. So x can't be negative 4. So you take the denominators and set it equal to 0. So when x is negative 4, or when x equals 3, there is a, it's undefined, right? We'll talk later about what that is. So take a look. The problems are negative 4 and 3. Those are the places where this function is undefined. So the domain is from negative infinity to negative 4, okay, union, negative 4 to 3, 3 to positive infinity. Okay?
Negative 4 have a bracket around it.
No. Can it be negative 4? Can x be negative 4?
No.
No. So we can't have a bracket because that would include the negative 4. Okay?
Why is it there then?
Huh?
Like, why is negative 4 there if it can't be there?
Well, it can equal negative 4, but it could equal negative 3.999999999. So we're good from here all the way to negative 4.000000001. It's just at negative 4 that it breaks. Okay?
From 3 to
Then why is it written like negative 4 3? Why is
From negative 4 to 3. So I have a region from negative infinity to negative 4, from negative 4 to 3, and then from 3 to positive infinity. These are not corner points.
No, yeah, but I thought it couldn't be between negative 4 and 3.
No, it can. It just can't be negative 4 or negative 3. You can have 0 in here. Like you can have 2 in here. You just can't have negative 4 or 3. Okay. So let's factor this one.
You have to put like a union between.
You have to put union. Okay. So you take t, okay, so t minus 1 equals 0, t plus 1 equals 0. At t equals 1 and t equals negative 1, we have a problem. So take a look. Okay, so take a look. This region is all fine. That's negative infinity to negative 1. This region is all good, negative 1 to 1. And then this region is also good, 1 to infinity. Okay, now, the further we go, okay, as soon as you graph this, as soon as you factor this, you could skip to the final answer. You don't really have to show me this stuff at honors level, okay? No, none of this. You don't have to show any of this. Just factor and this. Okay. Take a look at the next one. So the next one too, right? You can't have x equal to what number?
Negative 8
or 10. Negative 8 or 10 can't work, but everything else can work, right? So one other way is to write for yourself is x can't be negative 8, x can't be 10, but it could be everything in between. So what's the domain? What do I write?
negative infinity. Negative
Okay, can somebody else pick up from there? Negative infinity to negative 8. What else? And 10 to infinity. Okay. Here, this is my favorite one. Can't be factored. So let's just take it as is and set it equal to 0. X squared plus 1 equal to 0. X squared equals negative 1. Square root. X is plus or minus root negative 1. What is that? I. What does that mean? That means there is no real value that makes that denominator 0. Think about it. Is there any number you can plug into x that makes the denominator 0? No. If the denominator can't get to 0, then there is no problem. So the domain is all real numbers. That's a trick question. So domain is negative infinity to positive infinity. And the reason is there is no real values of x. There are no real values of x that make the denominator equal to 0.
Question.
Quickly.
So for the one, like for C, did you mean to say like x can't equal 10? Or,
Yes, that's what I meant. Okay. Next, okay, so Pollen, hang on, Pollen, okay, quickly, go.
It's just for all real numbers, can you just do the like weird
No,
bar?
this one. We're in calculus notation now. Okay. Okay. So, polynomial functions, all good. We talked about rational function. Next, let's come to radical functions. Okay. The domain of a radical function with an even nth root is the numbers for which the radicand is greater than or equal to 0. So, if you have the square root of x, the 4th root of x, the 8th root of x, the radicand, the filling, the stuff inside can never be negative. Can it be 0 inside? Yes, because the square root of 0 is still 0. Just can't be negative. But if you have an odd root, like the cube root of x, that's a whole other issue because the domain for those is all real numbers, right? Can I have cube root of 8?
Yeah.
Can I have cube root of negative 8?
Yeah.
Yeah, it's negative 2. Think about it. But nothing. Negative 2 times negative 2 times negative 2 is negative 8. So,
you can't have square root of negative.
right. Cube roots, odd roots, all real numbers. Okay. So here, state the domain of each function. So what you want to do is you want to take this and say it has to be greater than or equal to 0. So 7x greater than or equal to 70. X is greater than or equal to 10, but we don't like that notation. So we're going to do 10 to positive infinity as the domain. Okay. Now, next. Okay, so this is where we're really going to rely heavily on algebra 2 stuff.
How do you know which way the triangle be and head?
Well, it can't be negative. It has to be greater than 0. That's all the positive numbers. Okay, so this one has to be greater than or equal to 0. Okay? Now, this is not a linear function. This is a quadratic function. So, you factor it. Okay, so when you have something like this greater than or equal to 0, did you guys do this last year with the sign chart where you do a number line with like? Yeah. Okay, so you have to do a number line. On the number line, you put the zeros of these functions, of these parentheses. So -3 and +5. So now I've split my number line into how many regions? 3. Now what I want to do is I want to test points from each region, plug them in here, and see if it'll make the whole thing positive or negative. So from here, let's do -4. Okay? I plug it into the factored form. So I say -4 minus 5, -4 plus 3. And look, I don't care what the values are. I just care if it's plus or minus. Is the first parenthesis going to be negative or positive? Negative. How about this one? Negative. Okay, so negative, that's positive, right? So here I put positive. What's the next one? What number from the next one? 0. Whenever you can, do 0, right? So what's 0 going to give me? Negative here, positive there, so that's negative. Next one, let's take like 10. It's going to be positive, positive, positive. Okay, so what is it that I want? I want the region that makes this whole thing positive or negative? Positive. So it's this and this region, correct? So now I need to figure out how to describe those regions. Shane, I'm just gonna call you out. Sorry, you can be wrong. It's okay. No pressure. How can I describe this region? Where does it start and where does it end?
Goes from negative infinity to negative 3.
Good.
Then
Union,
Yeah. And then from 5 to infinity.
Okay, now I have a question for you guys. Can it be 5? If I put 5 in here, what do I get? 0. Can I have a 0 underneath? Yes, I can have a 0 underneath. So I can actually include these points. Huh?
Oh, if you put in a 0, so it's 0 squared minus.
Now if I put in a 5, huh?
That turns negative 15.
No, not if I put in a 0. If I put in a negative 5, no. If I put in a 5, I get 0.
Oh, I see.
But you can
But you can have 0 underneath, right? In the square root. Okay? Yep. Okay. What about the next one? What kind of root is it? Cube root. So what's the domain? Negative infinity to positive infinity. Huh?
you don't have to do any work to show. Yeah.
What's this one?
Square root of something.
This is a square root
Of 9x minus 2.
This is a square root of 9x minus 2 cubed. Okay? Because remember, when you have to the power of a fraction, the bottom one is the index here, the top one is the exponent. On the outside, this is a square root. So then we need the stuff inside to be greater than or equal to 0. So this has to be greater than or equal to 0. The cube goes away, right? Because you take a cube of both sides, a cube root. So x is greater than or equal to 2 over 9. Okay, how do I write that? 2 over 9 to positive infinity. Closed. Okay, now take a look at the next one. What's the problem here? There's a square root and it's on the bottom. So now you have two issues. Can't be negative, also can't be 0. So now when I say x plus 2, it's now greater than 0, not greater than or equal to, because it also can't be, right, 0 in there. So x is greater than negative 2. That means the domain is negative 2 to infinity, but it's open now. Okay, so when it's on the denominator, both of them take effect. Oh, now look at this one. Things are getting pretty hot over here. Okay, what's the issue? What's the issue with the numerator? Can't be what? Can't be negative inside. So x minus 3 has to be greater than, can it be 0 inside the x minus 3? Can the x minus 3? Yep. What else is a problem? The denominator also can't be 0. So I have two conditions that must be satisfied. X minus 6 cannot be 0. So x has to be greater than or equal to 3. And also, no, x just can't be 6. It could be less than 6. It could be greater than 6. It just can't be 6. Okay, and now it's all sorts of confusing. You know what? Let's just put it on a number line because when we look at things visually, it makes sense. The first part says x has to be greater than or equal to 3. You know what? Let's do this algebra 2 style. That's what that looks like, right? We know what that means. The second condition says, hey, x can't be 6. X can't be 6. So, can it be 3?
Yes.
Can it be 4?
Yeah.
Can it be 7?
Yeah.
Just can't be 6. So, the way in which I need to write that, though, I need to split it up. So my domain is from 3 to 6, can be 3, can't be 6, from 6 to infinity. Isn't that a fantastically efficient way of writing that? Right? Okay. Okay. I think G is the same as the one we did before. Yeah, let's skip G, because we did it already. We're not really skipping it. Okay? By the way, on tests or quizzes, make sure these are like not ambiguous, right? Make sure your brackets look like brackets and your parentheses look like parentheses. Okay? Okay. What's the issue with the next one? Can't be negative. Can it be 0? No. Greater than 0. So 2x, I'm sorry, so x is just greater than 3 over 2. So we're going to do 3 over 2 to infinity for the domain.
Why can't it be equal?
Yeah.
You tell me, when if